Okay, here's notes number 2 for 8.2, 24 through 26. Use properties of parallelograms. Okay, so let me go to that page. Okay, it says here use properties. Properties of parallelograms. Theorem 8.3. It says a quadrilateral is a parallelogram, then its opposite sides are congruent. So the original standard, it will usually say that these sides are parallel, and 2 arrows means that opposite sides are parallel. And then what this theorem gives you, and I'll put it in pink, is it says opposite sides are congruent. So you can say that the top is congruent to the bottom and the left is congruent to the right by putting these slashes. And so if PQRS is a parallelogram, then it says RS will be congruent to QP, and RQ will be congruent to PS for this theorem. Theorem 8.4 says, okay, if this quadrilateral is a parallelogram, that means we're back to just knowing these sides. These are properties of parallelograms. Saying it's a parallelogram means opposite sides are parallel. Then also what is given to you is the fact that opposite angles are congruent. So I'll put this in pink. Opposite angles would be angle Q would be congruent to angle S. Or angle R, I'll put 2 arcs, will be congruent to angle P. When it says opposite, that means across from each other, not adjacent. So to fill in the sayings here, PQRS is parallelogram, then angle P will be congruent to angle R, and S will be congruent to angle Q. They're opposite, they are congruent. Okay. In Theorem 8.5, it still starts with the same thing. Quadrilateral is a parallelogram. Then the consecutive angles are stream. They're calling them consecutive angles because remember, if you have 2 parallel lines, because this is still given to you because it's a parallelogram. This is the same thing as parallel lines cut by transversal. X and Y are consecutive interior angles, and we know that consecutive interior angles are supplementary. So that means that X plus Y here will add to 180 degrees. And if you go across the top, parallel lines here, cut by a transversal going in that direction, X and Y will also be 180 degrees. So it doesn't matter which way you go on a parallelogram, consecutive angles will add to 180 degrees. On Theorem 8.6, I squeezed it in on the bottom down here. Another property, there's 4 properties of parallelograms you got to know. It says quadrilateral parallelogram, then the diagonals bisect each other. Remember, bisect means to cut in half. So for this particular setup, I forgot to put the parallelogram symbols. But when I draw the diagonals, they actually bisect each other. And that's why I put an M here. Usually, remember, M usually stands for the midpoint. So we can say that QM is congruent to the other side, which is MS. And then PM will be congruent to MR for that particular setup. So these diagonals cut each other in half, bisect each other. Alright, so there's 4 properties of parallelograms. Not only do they have opposite sides parallel, but opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and the diagonals bisect each other. So there's 5 traits that you've got to know for parallelograms. Okay. Alright, our examples. Example number 1. We have a parallelogram given to us. They want us to find X and Y. If I'm looking just for X, realize these are opposite sides, and we know that opposite sides are congruent. So that means I'm going to do X plus 6 is equal to 13. subtract 6, and it tells me x is 7. It's a straightforward problem there. And then to say y, to find out what y is, remember f and h are opposite angles, and we know that opposite angles are congruent, so that means y is 68 degrees. If I wanted to find g or j, then I would have to take 180 and subtract 68. That's 2, and find out that these angles would have to be 112 degrees. But for this problem, they just wanted to know what y was. On example 2, it says a gate containing several parallelograms. Here's my odd looking gate. I kind of messed it up a little bit, but basically you see little parallelograms everywhere. It wants us to find, it's supposed to be an n, find the measure of ADC. So ADC, let me put this in blue, is that angle on that side, but they tell me that DAB, this angle up here on top, that angle is 65 degrees. So if I look at this a little bit bigger, I'm looking for that angle, but this one is 65. Now these are consecutive interiors. They share a side of the quadrilateral. That means they are supplementary. So if I put an x here because I'm looking for it, that means I know 65 plus x will be 180. If I subtract 65, 5, 7, 1, 1. That means the measure of angle ADC would be 115 degrees. Okay. On example 3, they gave us a coordinate grid here, so I tried to draw it as best as possible, but I also put the coordinates on here to help you draw it. But they're saying the diagonals of this parallelogram, and that's the symbol for a parallelogram, by the way, intersect at the point W. They want to find the coordinates of W. Now, one way that is straightforward, in case your graph is all messed up, is to find the midpoint formula of TV or of SU. So that's what I'm going to reference for this one. Remember, your midpoint formula was your coordinates added together and then divided by 2. So if I take the midpoint of TV and let me do my coordinates, the x's is 1.5 plus 4.5, and the y's are 5 plus 0. Okay? 1.5 plus 4.5 is 6, I believe, over 2, and then that would be 5 over 2. So if I divide this, it tells me the midpoint of the segment TV would be 3 and 2.5. 1, 2, 3, and 1, 2.5 would be a rough estimate to see if that's where that is. I realize if all I was given was those coordinates, I knew it was a diagonal, that's all I'd have to do. But I do want to show you that they match. If I do the midpoint of SU, doing the same setup that I had, the x's, that would be 0 plus 6, and this one would be 0 plus 5, and that ought to show straightforward to you that I'm getting the same exact answers here. So the midpoint of the coordinate W, so I guess I ought to write this correctly. W, the coordinates of W, my W wouldn't write, are 3 and 2.5. Do not put an equal sign there. Those are your coordinates. Okay. On the next page, my page 26, if you have room, keep writing, are 3 practice problems. So pause these. There's 1 and 2. Pause and copy and work. And then there is number 3. You can pause, copy, and work it. And then I'm going to start working them. Okay. On On number 1, we are given parallelograms, and we know that the diagonals bisect each other. Let me put that on the side here. Diagonals bisect, which means they're equal. Oops, sorry. There you go. So I'm going to find, let's go with x, just do it alphabetical. If these bisect each other, means those two parts are congruent. So I'm going to do 3x plus 6 is equal to 12. Subtract 6, that gives me 3x equals 6. Divide by 3, x has got to equal 2. If I go the other direction, I'm going to change colors, but I need a dark color so it copies. I'll have, remember, the other side are congruent. So I'm going to have 2y plus 9 is equal to 27. I'm going to subtract 9 and have 2y is equal to 18. Divide by 2, and that means y is equal to 9. Alright, on number 2, I have a parallelogram, and remember the opposite sides are congruent. So I can set this problem up doing c minus 5 is equal to 20. If I add 5, I get c equals 25. And then for the d, remember opposite angles are congruent, so I'm going to do d plus 15 is equal to 68. So if I subtract 15, d is equal to, looks like 53 on that particular answer. Yeah. And now on number 3, it says the measures of one of the interior angles of a parallelogram is twice the measure of another. Find the measure of each angle. With this one, I gotta first kind of see what was going on personally. One of the angles is twice the measure of another one. Okay, so one of them is x, the other one is twice x. So that means this guy would be x and this guy would be 2x because opposite angles are congruent. But also remember, I see it, these guys are consecutive interior angles, which means they are supplementary. So I'm going to take 2x plus an x and set it equal to 180 degrees. Well, that gives me a total of 3 x's. Divide by 3, and x has got. Okay, if I had the 180 degrees and divided by 3, that gives me 60 degrees, and that divided by 3, that's x. And then my other angle would be 2 times x, which 2 times 60 gives you 120 degrees for your two angles. And there you have it. If you got all of those correct, give yourself a big smile for getting the notes correct on parallelograms.